Hello, I'm Dr. Zia Tahir. This video tutorial is solution to problem 4 by 14 from Engineering Mechanics Statics 9th edition by J.L. Meriam, L.J. Craig, and then Jen Bolton. Statement of the problem is determine the force in member BC and BG of the loaded truss. So here is BC and then here is BG. So this problem can be solved either using method of sections or method of joints. If I try to draw a cut from BC and BG, so that is a possible cut. Okay, so then there are four unknown members on that. So for four unknown members, it's not wise to use method of section. So then I can use here method of joints. And for method of joints, so I can start from any of joints. So these are steps to find member force using method of joints. So you need to select a joint with at least one known force and two or less than unknown. So there is 3 kilonewton known force. So at joint C, there are three unknown forces. Joint D, there is one known force, and then there are three unknown member forces. At joint D, there is one known force, but there are four unknown member forces. So no joint satisfies this condition. So need to determine support reaction first. So now I'm going to find support reaction. So this is a symmetrical truss because a line of symmetry can be drawn, and line of symmetry is a straight line that divide truss into two mirror images. So it is going to divide it to mirror images, reflecting every joint and member on the one side across this line map exactly onto the geometry. So like as BCH and DHE triangle, they are exactly similar. All joints and all member are exactly mirror image of each other. So this truss is geometrically symmetrical, and then the load is being applied on line of symmetry, and then this is a symmetrically loaded truss as well because loads are applied on the line of symmetry or on mirror pairs about the line. So at joint C and joint D, so both loads are 3 kilonewton. So this is a geometrically symmetric and with symmetrical loaded truss. So when there is a symmetrical truss, so for that symmetrical truss, only one half about line of symmetry need to be analyzed, but here we have to only find BC and BG. So to need find vertical reaction, so vertical reaction at two symmetrical supports are equal. So both A and F, they are symmetrical, so they are at the same level. So reactions are equal. Each is equal to the half of total vertical load. So reaction at A and reaction at F, so both are same and they are equal to sum of total vertical load. And then horizontal reactions are zero. Horizontal reaction are zero. What's the condition for that? If there is no horizontal load, as there is no horizontal load, so horizontal reaction is zero. So the support reaction lines are vertical. So both of the support reactions are and vertical, and both pin and roller are on horizontal base. So then support horizontal reactions are zero. So I can find simply vertical reactions here. So reaction at support A is AY vertical and at F is FY. So AY is equal to FY. Both reactions are equal and each is equal to half of the total load, and the total load is vertical load acting downward. So 3 plus 3 plus 2, so that is half of that is 4. So AY is going to act vertically upward because loads are acting vertically downward, and similarly FY is going to act vertically upward, and there will be no horizontal reactions on that. So once these reactions are calculated, so now I start analyzing the truss. Now the point one, select a joint with at least one load or force and less than two or less than two unknown. So then I can start with joint A. So for that reason, so I'm going to start with joint A now. Joint A is isolated and a known now reaction of 4 kilonewton is there. And then AB and AG, so they are assumed as in tension. So the angle BAG is 60 degrees because uh, if I just assume that as a, if I'm just assuming this as a equilateral triangle, and in that equilateral triangle all angles are 60. So then A, and then if I, let's say, there draw a point P, so APF is an equilateral triangle. In that equilateral triangle, angle A is 60. So now I need to resolve inclined member into their components and then need to apply conditions of static equilibrium sigma fx and sigma fy. So AB, it can be resolved into its two component ABX and ABY, AB acting towards positive x-axis and ABY acting towards positive y-axis. So then in vertical direction, I have only one unknown. So I'll start with sigma Fy equal to 0. And then there are two unknown in sigma in horizontal direction. So then I'll go for sigma Fx. So for sigma Fy equal to 0, ABY is positive and then reaction 4 is also positive. So then it comes as ABY plus 4 is equal to 0. So ABY is equal to AB sine 60 and 4 will go to the other side, will become minus 4. So AB comes as minus 8 over root 3, so which is minus 4.6188. Next, for sigma Fx equal to 0, so there are only two forces in horizontal direction AG and ABX. Both are towards positive x-axis, so they are positive. So AG plus ABX is equal to 0. So ABX is equal to AB cosine theta. So AG will become minus ABX. So AB I have just calculated minus 8 over root 3 cosine 60. So it is plus 4 over root 3 and that is plus 2.3094. So now interpretation of the sign of unknown forces, a positive value indicate tension, a negative value indicate compression. So because initially I have assumed all unknown member forces in tension, so then AB is in compression and AG is in tension because it is positive. Now the joint has been analyzed. AB is 8 over root 3 in compression, AG is 4 over root 3 in tension. So then a member in tension at a joint is in tension throughout. So now AB is in compression and then AG is in tension, and we are not going to consider their signs anymore because those signs are now written in terms of tension and compression. So now these results from joint A are being represented here. So I need to find BC and then I need to find BG. So from A, I can either go at B or G. So both joint B and G, they have three unknowns. So it looks like it's not possible to solve either joint B or joint G. The other possibility is I'll solve joint F and then find GF. But because this structure is symmetrical and in symmetrically symmetric cross under symmetric loading, mirror image member carry equal member forces and have the same sense both in tension or in compression. Now, because there is a line of symmetry here, so AG and GF, they have same force in magnitude and then in the sense of in the same sense. So that AG is in tension 4 over root 3. So GF must be in tension with 4 over root 3. So now using symmetry at G, there are 1, 2, and 3 known and there are two unknowns. So using joint G, I can find BG then. So at joint G, AG and FG both are in tension with 4 over root 3. BG is, I have assumed that is tension, and EG is a symmetrical member or is a mirror member of BG. So EG must be equal to BG. But I don't know that how much is the angle here ABG. So the angle ABG need to compute here. And for that angle, I can use triangle ABC because in the triangle ABC, AB is given as 2 and then AG is given as 3. So I need to find that angle AGB, which is going to make, and I only need know one angle BAG as 60. So I'm going to solve triangle ABG to find angle G. So I have assumed that instead of ABG, GBF triangle, and because both triangles are similar and both angles are same, so one way of doing it, first find use cosine rule to find GE, and then after using cosine rule, then uh, again using cosine rule to or sine rule to find angle theta. But there is a shorter way of doing it. I will draw a perpendicular from E on GF at E dash, and drawing that perpendicular because all due to all of that symmetry, so GE dash is 2 meter and EF dash is 1 meter. So then simply using angle 60, so I can find out E dash, which is one component EF. It has this as horizontal component and EE dash as vertical component. So EE dash is 2 sine 60. So that is root 3, and E dash F is equal to 2 cosine 60 is equal to 1. So once I have in GE dash E triangle, that is the right triangle. So I have angle theta. So opposite is known and adjacent is known. So tan theta is equal to opposite over adjacent. So I can find that theta as 40.893. So now for EG and BG, angle theta is 40.93. 40.893 is calculated. So now I can analyze that joint. So now for joint G, BG and EG, they are being resolved into their components. So BG, its one component is towards negative x-axis, its one component is towards positive y-axis, and similarly for EG, its one component is towards positive y-axis and one component is towards positive x-axis. So then here, because uh, there are two unknown in vertical direction and two unknown in horizontal direction, so I can either apply sigma fx equal to 0 or sigma fy equal to 0. So now I'm going to apply sigma fy equal to 0. So for sigma fy equal to 0, EGY is positive, BGY is positive, and then the load 2 is negative. So then I'll have here EGY plus BGY minus 2 is equal to 0. So EG and BG, they are the same. So then I can write that as 2BGY or 2BG sine theta is equal to 2. And then BG comes as plus 1.5275. So BG is positive. So because it is positive, so then BG must be in 10. So now BG is 1.5275 kilonewton in tension. So now BG is calculated as 1.5275 in tension. So the next one, I have to find BC. So I'm going to select joint B now. So for joint B, again, I need to isolate the joint and draw a free body diagram. Assume all known members in tension, arrows away from the joint. Then need to apply conditions of equilibrium, sigma fx is equal to 0 and sigma fy equal to 0. But before that, need to resolve inclined member into components. So joint B is isolated and its free body diagram is drawn. So then AB is in compression and the angle of AB with horizontal is 60 because this angle is 60. So then if I draw a horizontal line here, so these are the corresponding these are opposite angles, sorry, alternative angles, so that is 60. And then again in triangle BCH, all angles is an equilateral triangle, so all angles are 60. So then BC angle with horizontal is 60, and then BG, because I've just calculated that angle as 40.893. So the angle again that BG with another horizontal line, parallel line, so that is 40.893. So now there are two unknowns, but I need only calculate BC. So I'm going to solve this joint first. Now for joint B, It has three inclined members, and all those inclined members can be resolved into their components. So, like as BC is resolved as BCY and BCX, AB is resolved as ABX and ABY, BG is being resolved as BGY and BGX. And then there is only one unknown in vertical direction, which is BCY, and that is required. So I can apply sigma Fy equal to 0 for this joint. So for joint B, then it is BCY positive, ABY is positive, and BGY is negative. So BCY is required, so which is BC sine 60, and then BG will go on to the other side, it will become positive, ABY is negative. So after substituting the value of BG and AB, so BC is calculated as minus 3.4641, and that is actually its sign is negative. So BC is 3.4641 kilonewton in compression, and that is required. So now BC is 3.4641 kilonewton and BC is 3.46. The other one is BG required, which I have already calculated. BG is 1.5275 and it is 1.528. So both answers are correct as per answer given at the back of the book. So that is a complete solution of this problem. Thank you very much for watching.